I think it's the same opposite. Then it does switch, and then when they switch back, it does come out neutral. And sometimes, well, that was the most I can do with that was, okay, I can relate that to this.
Can you give me some references on that or more information on that?
That comes, I think, there are, it's Prisoner's Dilemma.
Right.
Are you familiar with
it? Yeah.
It's Prisoner's Dilemma.
Okay.
It's just another context.
Okay.
So I don't know if that's an accurate analogy to what you were saying or not, but that was what came to my mind as I was watching that. And then, of course, I kind of wondered from the very beginning, from your earliest assumptions, what is the role of complexity and unpredictability if you're saying that these fairly simple equations can predict logical consequences? Because in fact, they're never just two actors. Even if it's a husband and wife, they're each carrying a world in themselves. Different voices, their parents' voice, their culture's voice, their religion's voice, their gender's voice. So I wondered about that. Is it ever really just two? Can you?
Yeah, one thing that we're looking at is kind of related to this, is a smaller version of this, is let's say people have different ways of interacting. We can make networks of people where there's more than one way they interact with each other. So in the stylized version, we would have green connecting lines, red connecting lines, and how they're responding in those different qualities would be different. So we can put in, we were trying to formulate a way of putting in multiple ways of interacting. And the reason for doing that was one of the things we have in a conflict when it gets gelled, when it really gets intractable, is everything becomes unidimensional. So all these different ways of interacting still lead to the same trap that everyone is in, which we thought that model might help us understand the circumstances of how one way of interacting interacts with another way of interacting. And actually after this I'm going to a workshop on networks, and from what I understand there's a really nice, there was a really nice article in Science recently about networks in a social perspective, saying basically the social scientists concentrate a lot more on the details of what goes on in the nodes and the meaning of it, and the physicists tend to make things just circles and lines connecting them, and concentrate on the structure of the network, but not enough in terms of what you're suggesting or saying about in terms of the realism, what goes on at the nodes. I think we wanted to ultimately put some more meaning into this by doing some of those things. Again, it's a shadow, it's in a very stylized way, but ask the question, let's say a network can be more hierarchical or kind of flatter in the connections. So let's say you had two ways of interacting, and one network was more hierarchical and the other was flatter. What would the dynamics of that network look like? What would that do? And even questions like that, which are relatively simple to formulate, or the answers are unknown. So there are a lot of properties of interactions, even at this very shadowy level, that we don't know. But I think, to make it more useful and more realistic, would be to put in a lot of those things. But each one of those little steps is actually very difficult in terms of the underlying mathematics not really being well understood. So I think, the points you're raising are good ones. I mean, I think, the social scientists and the physical scientists are trying to approach this from different directions, right, both of which are good, I think. Right. So, this issue of multiple ways of interaction is actually something we thought about a little bit, but haven't put in yet. I mean, the other thing about, I didn't say it, but a model like this, and this is where this is all art in the same way that social science is all art. There are far too many parameters and possibilities here, and you have to sort of get a feel for what you think is going to be important. And actually,
which is true in any systems
right,
analysis.
Right. And initially, actually, I had the people switching very rapidly in opinions and influences. And actually, that averages out. That doesn't make much of a difference. It was actually more interesting when they switched and waited a long time. You know, so for the moment, there's enough richness in the time dependency. And in fact, in large studies of networks in the physical and engineering sciences, there's not enough emphasis on what happens when the properties of the network change. So for the moment, we're concentrating more on time issues, but I think, you know, what you're raising is very, very important and meaningful.
And then the other thing I was thinking, I was kind of drifting to different conflict situations I've been involved with as you were speaking, and I was going, yes, yes, okay, yes. When people, say in Cyprus, when one side suddenly bonds with the other side, that does make a huge, I don't know if I'm going to use your language correctly, but in my world, I would say it creates a whole different attractor. And what I don't know about, I mean, I don't know a lot about your model. Frankly, it was really challenging for me because it's just a completely different language. But what I wonder about is, does this model give you any clues about what can help that change happen?
I would say at the level that it's done here, I don't think it gives clues about that. It gives some clues if a change happens, how the dynamics may affect the other group, how both of them may respond to a change. But I don't think at this point it gives clues as to how to make that change.
One thing that it does for us, I mean, this is speaking for the team that has been working on these things, and this is literature that is a little less common, a little less familiar with Eiger students, because it's Morton Deutsch, it's not Barton, it's a constructive conflict resolution, not basic human needs and so on. But Mort fundamentally had this idea that the distinctions is fundamentally between destructive and constructive, this competition and cooperation, and this crude law can be revisited now in a way that he could not do 30 years ago, 40 years ago. We can build mathematical models that he could just dream of. And you should see more happiness when he started working with us on these kind of models, because just the sheer capacity, human capacity collectively to do mathematics and computing that we have in the last 40 years makes possible something that Kurt Lewin, Mort, just couldn't possibly, they could dream of, they could think, oh, it would be wonderful if we could do something like this. And this is coming up now, so it is literally emerging now. So this one observation. The second observation is that on complexity, I think that what we see over and over again in this kind of modeling is actually that conflict has to do with the collapse on complexity. That fundamentally what you see is that one of the features of an attractor is that the complexity of the system is unavailable to the actor.
Yeah.
That the actors is just deprived of a world of possibility that would be available to them if they would be in a different plateau in the system interacting differently with the system. So the other thing is that in this reading on complexity, two things. One is time and the other is randomness. It's that fundamentally conflict comes out as a bounded reality. It's a place where randomness is no longer operative in the way we would expect in a system like this, in which you do things over time and then it doesn't really matter if it is positive or negative, opposite or the same. And actually, what seems to be the problem is lack of randomness, lack of moment, lack of the possibility of switching from one to the other, which is counterintuitive in many ways, but goes back to the idea that conflict is not about agreement. Conflict is about the safety of the disagreement. the capacity to you and I disagreeing without that being that I need to kill you, or the relationship is over, or the world is going to be destroyed. So it's actually very interesting things, because if you think, for example, the last things that Larry was presenting on the genes, well, our body needs both. You need red cells, you need white cells. You don't need only one or the other. So the language of victory, of somebody winning or somebody losing, is ridiculous. What the gene actually does, what this communication system does, is simply to transform something that is in a neutral state so that it becomes either red or white. But red is good and white is good. I know also that I'm speaking to somebody who's very well aware of all these personal bodily challenges. So it's a beautiful moment in his own way. So the point is that while we frequently associate conflict with negativity, what I think is very helpful here is that actually there may be something helpful about distinguishing conflict from differentiation. So when you see those two actors, departing from one another, you can read that as, oh, terrible, this husband and wife fighting and killing kids and having violence. But it could actually be a beautiful differentiation between red cells and white cells. You see what I'm saying? It doesn't need to be morally good or morally bad.
Right.
It's just something that happens. And I think it's an important distinction that the conflict resolution field has done many, many, many years ago, of reconquering conflict. And say, well, conflict is not necessarily... The bad things is when you deprive the system of its freedom, when you deprive the system of its movement, when you deprive the actors within the system. And I think that in the end we are going to revisit Barton, not in a sense of the old-fashioned basic human needs theory, but on the system that deprives systematically some of their freedom, of their movement, of their rights to be generative of the complexity that happens when the system is actually allowed to be the system that it's supposed to be. Anyway, I'm very happy that Larry has been here. Any other comments? Any other questions?
Ask a couple of questions. I was introduced to general systems theory 35 years ago. So just in the last year, I've been tracking the different streams of systems thinking. And so I'm curious about the dynamical systems. Jamil asked, is this out of Jay Forrester's work? And I immediately said no, but then when I saw some of your loops, I wondered if maybe it was. And how does this relate to the complex adaptive systems work out of Santa Fe Institute?
Yeah, I don't know enough about, the little I've seen about general systems theory was that what I've seen, which is very, very limited, is it wasn't kind of as mathematical as this.
No, not at all.
So it doesn't really capture some of the issues. Yeah, this is a part of chaos and the other stuff. I have a book called Fractals and Chaos Simplified for the Life Sciences, for example. So this is related to all the other kind of nonlinear systems things, which is complex adaptive systems and all these other things. I mean, in agent-based models and lots of other things too. So what all those things share in common is that the systems are nonlinear. That is, they respond not always in a proportional way to the environment. And what we're seeing, to say it in sort of adaptive systems jargon, when we have simulations with 6 or 8 people, we're getting self-organization out of the system. The people are forming, breaking into 2 different groups, and so this is in the same genre of that and some of the other things that people at Santa Fe do.
Thank you.
As I was listening to your lecture, there are many questions that I come to me. But I think the most the fascinating question that came to my mind is about the presence of third party. I think the implication of this mathematical model that shows the prediction of interaction pattern is so huge to the conflict resolution field, especially because our self-imposed mandate is to, deal with conflict intentionally. So you're looking at the mathematic models with two actors, one individual, one as an individual, or one group or another group. Another good thing about mathematics is that you can, throw in mathematical, languages almost indefinitely. Would it be possible to introduce to this mathematical model, let's say another XYZ, or another actor, third actor, and then create a pattern of how three different groups or actors intermingle?
But we haven't, there are a couple of different ways of doing that. In the simulations that I showed you with multiple people, with 4 and 6 people, in essence that's like that, where all the actors are equal in a certain sense. There are kind of two issues here. This is, I think, described, where did I describe? There's some publication on it that said this, and maybe it's in the Peace and Conflict article, I don't remember. But one of the things we don't know, either mathematically, one of the issues we don't know mathematically is when you have 3 actors and you have a triad, certainly the third person changes the interaction between persons 1 and 2. And whether those changes can be built up of pairwise functions of pairwise interactions alone, we don't know. So what that means is we don't know when you introduce the third person. In the simulations I showed you of 4 and 6 people, there are only pairwise interactions. And we don't know whether adding the third person certainly changes the interaction between the 2 people, but we don't know if it changes it in a deep way, so you can't represent it by 2 combinations of 2 people interactions, or whether it changes it in a deeper way. In most other physical situations, you do model things as if they're the sums of pairwise interactions. But in other cases, there are some examples actually of gene interactions where that doesn't work. So there are issues in introducing a third party that we're not sure the best way to do it or what's the right way to do it. So that's one thing. The other thing, which is why I pulled this one up, is it turns out if you have a system in a blue box and you push on the system, you influence the system with the red arrows from the outside in this gene system, mathematically the influences affect the equations differently. And in fact, one of the things that we're trying to do with this is, since they influence each other let me see if I can say it simply, the internal parameters determine the values of the system and whether it's stable. But the red things from the outside the box only determine the values of the parameters, not whether the system is stable or not. So they have a different effect. So we're also trying to see, whether in the gene case there's a qualitative difference between intervening from outside of the system and influencing the system versus intervening from inside. So that depending on how the third party acts, they could have an influence which is different from how the 2 parties interact with each other.
I also sense the absence of the third party, but I think what is really fascinating about your model and the data that you showed earlier, that 2 groups in a marriage, like a woman and a wife, do well when they're both okay with themselves. And I was thinking a lot about federal systems around the world, and even societies that are in chaos. And I think it would be very interesting if you did
Hussein is from Somalia, so he's very interested in chaotic systems and how order comes about, and he has his lifetime dedicated to that. So any clue is very appreciated.
Yeah. So I think it would be very interesting if you did come up with maybe a similar formula to look at societies in different regions and see how the ones who actually feel we're okay as it is, how they do, and the ones who want something different. I think it would be very interesting to see. And I think as a conflict resolution, people, I think a lot of us believe that the solution does not really come from the third party. It is the two actors. And if the two actors do not want solution, it will never come around. I mean, you can spend 100 PhDs and 100 third actors, but I think that data is, I think, fascinating and tells us a lot. And it's applicable, I think.
Yeah, I don't know what to measure in terms of societies. I mean, in a way, this comes back to your question of, what's going on in those groups internally and how it relates to the other group, involves a lot of different variables. I'm not sure this model is really capturing those type of things.
Sort of piggybacking on some of what has been said, I wonder how your mathematical model can, how you can include the variable of the structure within which these actors are working. And I was looking for that as I was going, because we don't act in a vacuum, party A and party B. We're informed by our own ontology and epistemology, but also all of what is going on around us. And I do think there's a lot of merit to the whole intra outlook that you have got going here. But how about the structure and also the triggers that come from the interaction of the individual and the structure?
Right. In terms of these red blood cells, the blood cells, we have to deal with that explicitly. So each of these arrows represents about 24 other chemicals, 24 other factors that interact with this little unit inside. And one of the things we're trying to do is to try to understand, one, how does that change the dynamics of the system? And second of all, why is biology like that? I mean, human beings are like that. What is the evolutionary advantage, or what are the advantages of the system for having many interacting things? Because we're also trying to ask, why is that? And what is special about that? And what does that create in the interactions when you don't have something like that? So at least until recently, and again, to go back to what I said about analogies, most of what we do in science actually is based on analogies of things we've built. It's really engineering analogies. So something like homeostasis, that we want everything to stay the same in the body. It's because we built things that we want the systems to stay stable. And a lot of our thinking has always been, much more than we realize sometimes, motivated by just looking at the machines we've built and thinking the world works like them, which it doesn't. It works like however it works. It doesn't work like those machines. But we're trying to understand, so what I was saying, most of the machines we build are very modular. They have pieces where this piece does one thing and this piece does another thing and this other piece does a thing. We're just beginning to try to engineer things where the pieces interact. This is the reason why we have a hard time understanding ecology or the atmosphere or things like that. So we really don't have a good sense of how systems behave when all these things interact, or even the simpler but more important question, what are the characteristics or the properties that a highly interacting network system has that most of the systems we've built so far don't have, and that we don't have a good sense of. So that's one of the issues that we're trying to deal with.
Yeah, you talked about There was a section where you talked about switching strategies, where you mentioned like one group alone, and then it kind of evolves into same and then opposite opposite case. At least looking at this from a conflict resolution perspective, I can relate this somehow to group fragmentation. For example, during peace processes, we see that often and again, where one group start out with an ideal, either with government or autonomy or whatever it is, but as the process unfolds, fragmentation happens. And sometimes some of the fragmentation even happens when there is the prospect to achieve that ultimate goal. So like during the peace process, during the negotiation itself, because then some parties are going to spring up who are maybe dissatisfied with what's going on, and so on. So at least there are some other variables that it comes back to the earlier point, how some of these other factors can actually impact and determine how the group pans out. Because most of what happens is, as soon as the common enemy disappears, almost something else springs up which acts as a wellspring for groups to be dissatisfied with the outcome of what they're anticipating. So I kind of found that interesting. And also looking at the complexity of conflict, when you mention attractors, in my mind, I found it really hard not to think of, detractors on the opposite side. Attractors, something that actually, attract groups to a particular phenomenon, but at the same time, there are other factors on the side which can actually detract people from, or groups from actually going towards what is this attractor that will actually help them to solve whatever problem it is. And again, if we're talking about intractable social conflict, then you have the issue of how groups are attracted to whatever these attractors are. Some groups go there willingly, but others have to be cajoled, they have to be pushed, they have to be prompted. So in a way,
let me clarify just for a moment.
Sure.
Attractors are not necessarily good or bad. At least not in this particular approach. They are simply the way you do things. They are patterns.
Default
attractors.
Default settings sometimes.
Yeah, it's just that the way you do things. This is the way you do things.
Right.
Okay.
Yeah.
So in that sense, it's not that each of us, psychologically, sociologically, we have attractors in our daily experience that we just go to.
Mm-hmm.
And the idea is that when you have a perturbation, after a while you go back to that particular way of doing things.
Yeah.
So there are certainly there is a very important dynamic between repellers and attractors. Repellers being the conditions in the system where you do not go, where you cannot go, where you are forced not to go, and you can create repellers in different ways. So in that sense, you are absolutely right. But it's important for us to distinguish attractors from an overly judgmental idea. I think that even for us, at the beginning, Peter was speaking of conflict as attractors. But most recently we are getting to the idea that attractors are attractors. It's just that it's one particular conditions in which you have a loss of complexity, you have a loss of randomness, you have a pattern that is repeated, is recurrent, and. But I interrupted you.
No, it's okay. Actually, I think that was almost I was at the tail end of whatever. No, I was just I'm thinking from a social science, lens, conflict resolution, where we just like almost always thinking about the complexity of, because my main interest, for example, is in post-conflict peace building, which can be a very, very chaotic process. So where you feel like after 10, 15 years of fighting, people would at least have learned some lessons, say, hey guys, this is not worth it. Let's just get along. But then we find that most often it just doesn't work that way. So in a way, I can, I'm not mathematically inclined, I must admit, but at least I can see some correlation between, sections of the model, at least with some of the issues that I think some of us are interested in.
What I want to emphasize about what you said is that, in some of these types of models, there's been an underestimate of what you're saying about, the groups breaking up into different things as the peace process goes on. There hasn't been enough thought that the dynamics itself is dynamic, that the underlying things can be changing, and that adds a greater richness. And this is one of the issues in the prisoner's dilemma, because you have a fixed structure and then you play out the game. And what we're seeing here is if you keep changing the rules of the game, then you can get things that are much more efficient or can do much more interesting things. This is, again, the lesson